Okay guys, I'm going to do another video. This one's going to be about bond lengths and a little bit on SP hybridization. On another video I think I may go a little bit further into SP hybridization and what that actually means and what the atoms look like as far as orbitals go. But for this problem, it's just going to be a quick practice problem. I use a college textbook to kind of outline the chapters, so if you guys have any questions or anything that you would like me to work through, I will do that. Just send me a message and I'll try to work them out. Alright, this question starts off by asking, label the shortest carbon-carbon single bond. Well, this is going to depend a lot on the hybridization of each carbon, and we know that this carbon here is an SP. Whoa. This one isn't. Sorry guys. Alright, this one is an SP hybridized carbon, and the carbon that's right next to it on the other side of the triple bond is also an SP hybridized carbon. This one is an SP2, this is SP2, this is SP3, and this is SP3. Okay, so it wants us to label the shortest one. Well, as we can see here, this carbon right here and this carbon right here are going to have more %S character because this is an SP2 and this one is an SP. There's going to be more %S character in this single bond than this single bond and this single bond, because this is an SP3, this one is an SP3, this one is an SP2 hybridized carbon. Now, when they're overlapping, like when you talk about the bonds that they're sharing, it's going to be a bit different. You'll say like this one is an SP3 orbital overlapping with an SP2 orbital, and so we'll get into that in a different video. But for this problem, we're just going to assume that these are the carbons hybridizations right here. Okay, so the shortest one is going to be this bond right here because it has more SP character, or more S character. Okay, label the longest carbon-carbon single bond. Well, obviously if we look here, this one's going to have more %S. So if you have these two bonds sharing this, it's not going to be as long as this right here. So one will be the longest. Okay. The next question is, considering all the bonds, label the shortest carbon-carbon bond. Well, considering all of these bonds, even the double or triple bonds, it's easiest to tell that the SP hybridized carbon bonds here are going to be the strongest, or the shortest, and the strongest, but that question was asking for shortest. Okay, next question, label the weakest carbon-carbon bond. Well, that's going to go back to our hybridization. SP3 and SP3 are going to make this the weakest. Weakest and longest, and then this one will be the shortest and strongest. Okay, now label the strongest carbon-hydrogen bond. Well, it's going to be this bond right here. The carbon bonds, like the bonds to the carbon get shorter the more %S character you have, and this is going to hold on to this hydrogen even more. So this will be the strongest carbon-hydrogen bond. Okay, explain why bond 1 and bond 2 are different in length, even though they are both carbon-carbon single bonds. Well, the bond 1 and bond 2 are different lengths because of the SP2 and SP3 hybridization. So this is an SP3 and an SP3, and this one is an SP3 and an SP2. So that means that this bond will be shorter than number 2 will be shorter than number 1, and we'll get more into that as far as like orbitals go and the actual appearance of the atoms and all. Alright guys, well as always, if you have any questions or anything, just feel free to ask, and I don't know where this is going to go. I'm just going to try to follow the book, and if you have me go elsewhere, I'll do that. Alright, well you guys have a great day. Bye.